ClearPath OS 2200 QProcessor High Availability Cluster Details. In this presentation, we'll take a look at the high availability cluster that can be configured for the OS 2200 QProcessor. We'll dive down into the details in this presentation. When considering the high availability cluster that operates on the QProcessor, the first thing to identify are cluster resources. Some of these are required while others are optional. A cluster resource is a component that's added to the HA cluster software and monitored for health. These are typical cluster resources on a QProcessor high availability cluster. These include MQ file systems, network resources such as the OS 2200 connection and the public LAN connection, and then queue managers and their objects. The objects may be optionally added to the cluster for monitoring. You'll want to add the system components to the cluster in what's defined as an HA resource group. There may be more than one groups on your system. A group consists of MQ storage. This is the file systems that will hold your queue manager data and logs. Next, it includes network resources such as the access points for the OS 2200 and the public LAN. Next, it includes queue managers. A given resource group may contain one or many queue managers. You can decide how to create groups based on your needs. All MQ data and logs created on external storage are grouped into what we call MQ storage groups. To create MQ storage groups, the first thing you need to decide is what are the queue managers that are needed for access on this particular QProcessor. After the queue managers have been identified, determine the groupings. Groupings are defined by collecting one or more queue manager into the same MQ storage group. Then, from your available LUNs on your external storage, select which LUNs will hold each queue manager group. So the MQ storage group for production might be housed on higher performing disks than, let's say, your queue managers that you use for test. The MQ storage group lets you decide how to collect up your queue managers into hardware groupings. Once allocated to a certain storage group, the queue managers themselves can be moved from one to the other. The MQ storage groups and external storage is required for high availability. You create the MQ storage group using the Administration Console GUI, the Configure External Storage module. As I have said, once the MQ storage group and the queue managers are assigned, the queue managers can easily be moved between groups. The first group that is created on your QProcessor becomes the default storage group. This means anytime a queue manager is created on this system, the system will automatically place the queue manager on this storage group. Now let's take a look at file systems in the cluster. Typically, you have a bunch of shared storage, and we recommend that you use something like EMC PowerPath so that you have redundant SCSI devices. Once the EMC PowerPath device has been identified, this would be equivalent to the LUN in the previous slide, we create an LVM Logical Volume Manager header onto this device. If you wish to back up your queue manager data, we use the LVM Snapshot feature. The LVM Snapshot feature allows us to take a backup of the queue manager data with minimal downtime to the queue managers. When defining resource groups, you can assign them to their preferred system. With two nodes in the cluster, you can distribute your one or more resource groups between the two cluster nodes. All resources in this group will run on their preferred system whenever possible. So by setting the preferred system, you're pinning the resource group, this is network resources, MQ resources, and the storage resources together on this system. Now, if there is some failure in one of the resources and the cluster just can't start it again, or can't stop the resource for that matter, the cluster will move all the resources in the group over to the remaining node. So they'll all shut down systematically and then restart on the other node, like in a node crash. So if the node crashes, all the resources are going to restart on the remaining node to provide you with high availability. The thing to consider is if the preferred system is set to the crash node, when that node comes back up and the cluster services start, the resources will automatically move back. Now, this may or may not be a desirable behavior for your site. If you want more control over the moving back of resources, there is an option called HA Cluster Operations Start at Boot. You can set this to no. The default is yes. So if it's set to no, you will have to manually control the failback to the preferred system. When the system boots, the HA services will not automatically start, and then the resources will not automatically fail back to their preferred system. Another way to prevent the failback is to change the preferred system. So if there's a problem with one of the nodes and all the resources move to the remaining node, you can edit the resource group preferred system to stick that set of resources to the node it's running on. If you do this, once the other node becomes available, comes back up, the resource and their group of resources will not move then. For the HA cluster monitors for basically three kinds of failures. Resources in which the resource won't start, a failure in that the resource won't stop or won't respond to a stop action, and failures where the resource is running and the monitor action detects that the resource isn't running. So that's a failure while it's running. Now, depending on the type of failure, different default actions are taken. With start failures, the HA cluster software always tries to start it again, unless a configuration is detected. That's considered a hard down, then it doesn't do anything. If it can't stop a resource, the cluster considers that a really serious action. So it resets the node, basically reboots the system, to clear the failure to stop. This gets the system cleared and the resources then can continue once it restarts. Each resource has special software associated with it for monitoring. The HA cluster software will call the monitor several times depending on a configuration value. If a failure is detected, the cluster will stop the resource and then attempt to restart it. This cycle continues until a threshold is reached, whereas the cluster will move all resources in the group to the remaining cluster node. There's a concept called failure counting in HA. For all resources in the cluster, you can configure what we call a migration threshold. When the threshold is reached within a default failure timeout, which is defaulted to 60 seconds, then the resource group migrates to the other cluster node. So start and monitor failures are counted. Let's say you have a resource that is not behaving. It can't start itself. The cluster tries to start it and for some reason won't come up. The cluster will then stop it and restart it. And if this happens continuously, let's say you set your migration threshold to 5. If it can't restart it 5 times and this all occurs within the 60 seconds, the cluster will stop all the resources and their dependencies, which is everything in this resource group, and move it over to the other node. If it can't start it there, then it just gives up and stops it. You have to use manual intervention to clear it. And now if it's an intermittent failure, typically what happens is that the failure timeout will reset the failure count. So if you have an occasional failure once every week or even once every few minutes, you won't be getting any movement of the resource. The cluster will restart the resource, make sure it's up, and then the failure counts will reset. Hard failures, as I said, are if the resource is not configured correctly and cannot start. Also a hard failure is if the migration threshold is reached on both nodes. We have a failure link that you can follow to detect why the resource failed. This is typically a code 6 is a hard failure. We also have a cleanup feature where you can manually reset the fail count, restart the resource and its dependencies. So in some cases the failure may require manual intervention. And you can do this behind the scenes and then clean up the resource, and then you'll be back up and running. Most cases the cluster can restart the resource though. Let's take a look at resource dependencies. In a given resource group, there are application access points, network access points, which comprise of the application access point to the 2200 and one or more public access points. Both IPv4 and IPv6 access points are allowed. Next are the MQ file systems, or the storage groups that we talked about. In this case, we're showing we have one storage group. It's comprised of both data and logs, and then the LVM devices. Then on top are the various queue managers and their resources. Adding trigger monitors, brokers, listeners, channel initiators are optional. In this case, we show a different configuration in which you have two storage groups. So if a failure happens in one of the data, or you want to be able to take down one data without affecting the other LUNs, you can do it with this kind of configuration. This completes this demo.